So again, I'm Jeremy Veldman with the Memphis Astronomical Society. That's our website. I am an amateur astronomer. I have been for most of my life. This is one of the telescopes that I use, 20-inch Dobsonian. This is a picture of the moon that I snapped from my driveway. I know you can't see it very well, but it's a great telescope. I also have a smaller scope, a Schmidt-Cassegrain type that I used, among all things, yesterday to see the lunar eclipse, super blue blood moon lunar eclipse, first time since 1866. I also use it to view the sun. So astronomy has been an active fascination of mine, as well as the planet Mars, which is more or less the topic of today's presentation. And I understand it's Space Week. Mars is the focus, which is appropriate because the study and the fascination with the planet Mars in many ways marks the birth of modern science. That's what we're going to talk about today. Now, Mars does have two of the most interesting geological features in the solar system. Olympus Mons being one of them, the tallest volcano in the solar system, dwarfs anything that we see on planet Earth. Mount Everest is the tallest mountain on Earth at 29,000 feet. You do the math on that, it's something like 6 miles. If you took Mount Everest and you put it next to Mons Olympus on Mars, it would be a little molehill. In fact, the Hawaiian Islands are actually the tallest mountain range on Earth. And if you were to take those scaled all the way down to the base of the ocean floor and put it next to Olympus Mons, it would be a little molehill. Olympus Mons being 2.5 times taller than Mount Everest, or 13.6 miles tall. If you were standing on Olympus Mons on Mars, you wouldn't even know that you were on a mountain because the base is so slow, the slope is so broad that you wouldn't even be able to see to the edge of that mountain. Valles Marineris, the largest canyon in the solar system, is also on the surface of Mars, and this dwarfs anything on Earth, including the Grand Canyon. I've been to the edge of the Grand Canyon. It is quite an experience, but the Grand Canyon would be a very small ditch, 18 miles wide, 1 mile deep, compared to Valles Marineris, 150 miles wide, and as much as 4 miles deep. Or if you can imagine a Grand Canyon that would roughly be as long as the United States itself, 2,500 miles long, 150 miles wide, 4 miles deep. So that's Mars. But really the fascination with Mars goes all the way back to antiquity. What you're looking at is a time-lapse photograph of the path that Mars traverses in our night sky over a period of about 3 or 4 months, taken by an amateur astronomer, Tunk Tunzel. And this is the path that the planets take as they wander across the sky. In fact, that's what the term planet means. It literally means wandering stars. Now, we take a lot for granted today because of technology and telescopes, but imagine for a minute that you're an ancient Greek or Babylonian 3,000 years ago trying to understand the motions of the heavenly bodies without any of the knowledge that we take for granted today. The sun, moon, and stars are relatively easy to figure out. Stars, they stay fixed. The sun and moon rise in the east, set in the west. But the planets are weird. They travel eastward, and then at times they stop and travel westward or retrograde. And then they stop again, and then they travel eastward again. And they make these loop-de-loop patterns. And it was really, really hard for mankind to figure out exactly what was going on, because the path that the planets traverse in the night sky is literally very, very complex and mystifying. Now, we know the answer today, but back at the beginning, Greek philosophers like Aristotle, trying to model what was going on 2,500 years ago, placed the Earth at the center of the universe and everything else revolving around the Earth, not only because we're egotistical and think that we should be at the center of the universe, but the concept of a moving Earth was inconceivable in the mind of ancient Greek philosophers. The Earth is just simply too big to move. Think about it. You pick up a boulder and you throw it. The larger the boulder gets, the more difficult it is to move. So the concept of a moving Earth was inconceivable in the minds of the ancient Greeks and Babylonians, and people trying to figure out exactly what was going on in the night sky. So they placed the Earth at the center of the universe, everything going around it, and it took the better part of 3,000 years for mankind to get beyond this. Now, fast forward, Nicholas Copernicus, right around the time that Christopher Columbus was discovering America, proposed a new idea, placing the sun at the center of the universe and the planets going around them. Ironically enough, trying to be more like Aristotle in his model, going back to uniform circular motion. A circle is the perfect geometric shape. So what else would the planets be doing except traveling in circles? The problem is, going from this, in order to model what was actually going on in the night sky, it became exceedingly complex. A very, very complex system of cosmic gearworks that was just very, very difficult to understand. So Copernicus tried to model the universe by putting the sun at the center and all the planets going around it. And it was met with considerable controversy, but the idea was out there. And following up from Copernicus were these two gentlemen right here, and what I classify as really the watershed moment in the history of science. And Mars was the focal point. Tycho did not like an Earth that moved, so he came up with a weird system where the sun and the Earth were fixed and everything else either went around the sun or the Earth. In order to prove his model, he studied the orbit of Mars for 20 years. This was before telescopes. He was the best naked eye astronomer of his day, and he came up with the very best data at this time of the orbit of Mars. 20 years worth of data. Now, when he passed away tragically, his protege Kepler picked up where he left off. He studied the orbit of Mars, assumed it was a circle, tried to fit 4 data points on the circle, but when he came to a fifth, he realized that the 5th data point didn't fit. And that was the watershed moment in the history of science, because he realized the sun does not, or the planets don't orbit the sun in circles. They orbit in ellipses, or squashed circles. So he came up with his 3 laws of planetary motion. Law number 1, a planet orbits the sun in an elliptical pattern with the sun at one focus, an ellipse being a squashed circle. We got lucky because Mars has a more elliptical orbit than any of the other planets in the universe. If Mars had Venus's orbit, we would still be trapped 500 years in the past trying to figure out exactly how this all works. Law number 2, the equal areas law. You draw a line from a planet to the sun, and they sweep out equal areas of space in equal time intervals. Why is the winter season shorter than the summer season? Because the Earth is slightly closer to the sun in the winter, and we travel a little bit faster around the sun in the winter than we do in the summer. Equal areas law. And then the 3rd law, the period, the amount of time that it takes a planet to go around the sun, we call it a year, 365 days. You square that number, and it's roughly equal to the radius of that orbit cubed. Without getting into the math, what Kepler tapped into was that there is a set of harmonic laws. There's an underlying set of physical laws that govern how the universe works. He didn't know why, but a generation after Kepler, Newton put it all together in the synthesis. He came up with his laws of gravitation that we still use today to build spacecraft and send them to the far reaches of the solar system. Before Newton, Galileo built a telescope, looked at the heavens, and he proved beyond the shadow of a doubt that 2,500 years of history, geocentric, Earth-centered universe was fundamentally wrong. The sun is absolutely at the center of the solar system. He saw phases on the planet Venus, much like the moon has phases. He saw moons orbiting Jupiter, meaning that there are bodies that go around something other than the Earth. And he saw sunspots and he saw craters on the moon. But Newton is the one who put all these laws together. And as a result, that is the birth of modern science. We go to the moon because we use Newton's laws of gravity. And fast forwarding a little bit further into the future, the existence of your iPhone ultimately owes its origins to mankind's 3,000-year struggle to try and understand the path, the meaning behind the path that the wandering stars or planets take in the night sky, starting with, among all things, the path of the planet Mars. So that is the birth of modern science. Now, what is science? How do we break this down to simplify it? It's essentially 3 questions. When you're looking at an object and trying to figure it out, what is it? Describe it. What does it look like? How bright is it? How far away is it? How big is it? Question number 2, how does it work? It took centuries to figure out how stars work. We now know that Einstein's famous equation, E equals mc squared, is what powers the sun for 10 billion years. Energy is converted, mass is converted into energy. And it can do there and sit there and shine for 10 billion years. And then the third, even more important question is, how does it evolve? Evolution meaning unfold or change over time. And this is, again, this is a lot of work. In terms of stars, astronomers use a tool called the Hertzsprung-Russell diagram to classify stars in terms of their brightness and their mass. And you see that they come in a variety of sizes. I mean, we're used to the Earth. It's a pretty big place. But planets are inconceivably small compared to stars like our sun. 99% of the mass of of our solar system is the sun. But even our sun is small in comparison to some of the other stars in the universe, like blue supergiant stars like Rigel and Orion or Eta Carini. But even the blue supergiants, as large as they are small compared to some of the other stars in our universe, like red supergiant stars like Betelgeuse and Orion, or Antares in the constellation Scorpio. And even those stars are small compared to hypergiant stars, like the gargantuan VY Canis Majoris in the constellation Canis Major. So stars come in a variety of sizes. The largest stars, big enough to swallow Saturn in its orbit. So they've been classified because of the tools and techniques of science in terms of their mass, luminosity, and size and physical characteristics. Getting back to Mars, 1984, the famous meteorite was discovered on the continent of Antarctica, ALH 84001. And when you take that micrometeorite and put it under a microscope, it has features that look a lot like microbial bacteria. Now, after further analysis, these structures can be explained without the existence of life. They're just physical erosion features. But Mars has been the subject of intrigue for a long time because it's the most Earth-like planet in our solar system in terms of possibility of harboring life at one time in the distant past. And it was believed, even though Mars is a cold, dead, dry, geologically inactive world today, it's believed that early Mars was more like this, similar to Earth. A thick atmosphere, a warmer climate, and standing water on the surface in the forms of lakes, oceans, and even streams. Detailed erosion features suggest that water existed at one time on Mars in the past, and it's been the subject of exploration. As recently as last month, water ice found exposed in Martian cliffs. The water went away when Mars's atmosphere was destroyed as a result of the solar wind. The magnetic field is what sustains us here on Earth because it keeps the solar wind from destroying our atmosphere and ultimately causing our oceans and lakes to boil away and life to die off. Mars in the distant past had a magnetic field possibly too, but the magnetic field died as the planet froze, and as a result we have Mars, a dead world. But there could be evidence in the past of water on Mars. And 4 countries on Earth, including the United States and the NASA program, are getting ready to send spacecraft to Mars in the next couple of years to explore the red planet and, among all things, drill down into the Martian soil to see if they can find evidence of past water on Mars. And where you have water, of course, you always have the possibility for ancient life. In addition, the Kepler Space Telescope, named in honor of the great scientist that we just talked about who formulated the laws of planetary motion, listening to the data that he had collected from Tycho and figuring out that the Aristotelian view of the universe is fundamentally flawed, in 2009 this space telescope was launched for one purpose: to find exosolar planets. Growing up, there were only 9 planets in the universe when I was young. Today, we know that there are confirmed at least 3,500 and growing. You can see the explosion in exosolar planets outside of our solar system in just the last couple of years because of the Kepler Space Telescope. Some of these planets larger than Jupiter, but a lot of them are more terrestrial or Earth-like. So there's the possibility of finding planets that are more like ours out there. In fact, they're already being discovered. Tomorrow night at the Memphis Astronomical Society, I'll be talking about some more of the other discoveries that the Kepler Space Telescope has discovered including advancements in our understanding of stars, the evolution of stars and galaxies, as well as some of the disturbing findings of planets that make our solar system very weird and very alien. Charles Messier, right around the time, about 100 years after Newton passed away, cataloged over 110 deep sky objects. At the time, people were starting to build telescopes, look at the night sky, find little fuzzy patches, didn't know what they were. Charles Messier set out to find comets, and as a result, he cataloged 110 deep sky objects, such as M42. We know this to be a stellar nursery now in the constellation Orion, out this time of year where young stars are being formed. M13, a globular cluster of over 100,000 stars, 10 billion years old. These are the ancient stars in our galaxy, visible in the constellation Hercules in the summertime. M57, the Ring Nebula, what our sun is going to do in about 5 billion years when it runs out of nuclear fuel, swell up into a planetary nebula. It's a beautiful sight, but it's really a stellar corpse. It's death. And of course, M31, the famous Andromeda spiral, a separate island universe 2.5 million light years away. Edwin Hubble measured the distance to the Andromeda galaxy in 1923. For 2 centuries, there were 2 competing hypotheses for the type of universe we live in. Is the Milky Way all there is, and these little fuzzy patches just gas clouds in our own Milky Way? Or are these little fuzzy patches separate galaxies like our own, or island universes? Edwin Hubble measured the distance to Andromeda, figured out it was 2.5 million light years away, outside of the Milky Way galaxy, and in 1923, he expanded the universe by a factor of over 100 billion. In his honor, the Hubble Space Telescope was launched 25 years ago, took this image. This is the Hubble Deep Field. You're looking at an image that subtends about a grain of sand in the entire night sky. Hold a grain of sand in your fingers, look through it for about 12 billion years into the past, and you'll see this. About 10,000 galaxies, each as big or bigger than our Milky Way, containing over 100 billion stars. And that's just one very, very small section of the sky, a grain of sand held at arm's length. This is 1/25 millionth of the sky. Our entire universe is filled with galaxies. They cluster together in groups, in superclusters, and in walls, filaments. There's structure to the universe. And if that's not even more ominous, we're now discovering an entire dark sector to the universe that is even more mysterious and yet unknown. Every star, every planet, everything that we can see, everything that we can measure, everything that we're experiencing in our life, in our everyday consciousness, makes up less than 5% of the universe. We're made out of atoms. The universe isn't. It's believed that 85% of the gravitationally attractive stuff, or matter, is actually dark matter. And 3/4 of the universe is made out of energy, a mysterious dark energy that's causing the universe to expand and accelerate in its rate of expansion. So, in 500 years, we've not only gone from realizing we're not the center of the universe, but we've come to realize we're not even made of the same stuff, for the most part, that the universe is. We're not made, matter, the stuff that gravitationally attracts the universe, is mostly dark matter. We're the debris of the universe. And the majority of the universe is made up of dark energy, and we don't know what it is. We don't know what's causing the universe to accelerate in its rate of expansion. But this was, if you had X-ray vision, not X-ray vision, but if you had all-knowing vision, this is essentially what you would see. The bright little dots here being clusters of galaxies, and then the other stuff being a cosmic web of dark matter that holds it all together. Think of the dark matter as scaffolding, like in a building or a structure that holds everything together. And the luminous matter, like stars, planets, galaxies, and ultimately us, we're just the very, very small remnants of the rest of the universe. So, sum it all up, Albert Einstein, the great physicist, wrote, "The most incomprehensible thing about the world is that it's comprehensible. We just happen to live in a galaxy where we can see all the way across the universe to the very edge of the cosmic microwave background. And we can see galaxies billions of light years away and analyze exploding stars to to get an idea, at least empirically, of what's going on in our universe. And that's essentially what the Memphis Astronomical Society is about. We're a nonprofit organization dedicated toward educating and informing the general public, those who are interested in science, those who are interested in astronomy, those who want to learn more. We meet the first Friday of every month, Christian Brothers University, and we have observing sessions twice every month. This is our website. I've got some postcards up front if people would like to learn more. But that's it. Tomorrow night is our next meeting, February 2, Groundhog Day. If you're interested in a career in science, get involved in an organization like this and keep following your passion. Thank you very much.